All right, guys, today we are finishing up our constructions notes. So first for this piece underneath, we're going to look at constructing an equilateral triangle, a square, and a regular hexagon inscribed inside a circle. So we'll talk about some vocab first here. I'm going to type it. Equilateral triangle is a triangle with all three sides the same that are the same measure. A square is a quadrilateral, meaning it has three sides with all four sides that are the same measure. So really what we're talking about here are regular figures. So an equilateral triangle and a square are what we call regular. A regular hexagon is a hexagon with all six sides that are the same measure. So if anything is called a regular figure, that means all their sides are the same. So a regular hexagon is a hexagon with all six sides that are the same measure. Inscribed means a shape drawn within the boundaries of another shape. So we're going to take circles and inscribe shapes inside of our circles. And really we're starting with circles because remember we're doing all of these constructions with just a straight edge and a compass, and compasses make circles. Diameter is a segment drawn through the center of a circle touching both edges. Okay, a radius would be half of a diameter. All right, so there's some vocab. Make sure you pause and get those written down before you move on to the next page. All right, so we're going to look at how to inscribe an equilateral triangle first, then we'll do a square and a hexagon today. So we're starting with a circle, but if you didn't have a circle, you can make one with your compass, but ours is already on our paper. But given circle A, create a diameter BC. And this can be anywhere, but let's go ahead and just do straight across horizontally here. I'm gonna move this down, but use your straight edge so that it's nice and straight through the middle. It says create a diameter BC, so that's what we'll label our endpoints, B and C. And then from here it says create a circle at C with radius AC. So radius from A to C, I'm going to stretch this, and they want us to create a circle at C. So I'm putting my pointer in on C and making a circle all the way around. Label the two intersections D and E. So right here is D, and here would be E, or if you had them switched, that would work too. Create BD, so now we're going to connect these here, and I'll use a different color. Let's do blue. So BD, BE, and ED. Now we have an equilateral triangle in there. So all of my blue segments here are the same measure. Okay, and we are finished with that one. All right, let's look at a square. So given circle A, let me drag my compass down here. Given circle A, create a diameter BC, so we'll start the same. Use your straight edge, make sure that's nice and straight. So here we have BC. Construct a perpendicular line to B through A. So in case you don't remember, this is where we want our perpendicular bisector steps. So this is like number 7 from yesterday's notes. So right here, this part C is like number 7. So I'm going to put my pointer on A, and I want 2 points that are equidistant. So I will put an arc here and an arc here. And I'll erase what's in the middle. Oh, it won't let me. Okay, Anyway, so this would be, we've already used B and C, so let's just say D and E. And then if you remember, we want from E to A, we want our thing to extend past A, our pencil to extend past A, and then we'll make an arc. And then without changing this distance, we're going to put our pointer on D to make the same arc. And then we can draw a line through these 2 points where they cross. Okay, so if I go a diameter this way through those points in the center, so this is part C. Construct a perpendicular line to BC through A. That we just did that part. So now we can connect these 4 corners here. Right here. 1, 2, 3, 4, and now that's a square. Okay, and these little tick marks I'm putting on here are showing us that we know the sides are all congruent. They have the same measure. All right, now a hexagon. Given circle A, create a diameter BC. So we're starting out the same way. Create a circle at C with a radius AC. Okay, so similar to how we started the equilateral triangle. So I'm going to make this line up to AC and make a circle at C. Flip. Okay, and then label the 2 intersections D and E. So far this is exactly how we made that equilateral triangle. So for our equilateral triangle, we just connected those 3, B, D, and E. Create a circle at B with radius AB. So since it's already the radius, it should be the same. So I'm going to put my pointer at B and make a circle. Label those 2 intersections F and G. And this should make some sense to us because a triangle had 3 sides and a hexagon has 6. So really we're kind of taking what we did before with the equilateral triangle and duplicating the sides. So we're doing 2 circles instead of just the 1. Okay, and then I labeled these 2 points F and G, and then it looks like we just need to connect them. And then again, this is a regular hexagon, meaning all the sides are the same measure. So if you want, you can put these tick marks in here. That's what that signifies. Right, that's it for our construction notes. So now you are working on worksheet 4. And then we are wrapped up with this constructions unit. So next week you can expect to take a quiz over constructions, but it will be open notes. You'll be able to use your notes from these 3 days.